Very good morning, my dear children. Happy to see you. In this lesson of oscillation, last class we had discussed about the topic of simple harmonic motions, which means SHM. Okay. In simple harmonic motions, we have derived an equations of force constant. A force constant is nothing but force per unit length. And one more topic we have revised, which means discussed the projections of uniform circular motions of a diameter of simple harmonic motions. Okay. And finally, what do you mean by displacement, velocity, and accelerations of graphical representations of simple harmonic motions? So, in this session, we are going to see what do you mean by time period and phase difference in the epoch. These are the topic will be discussed in our morning session. Okay. So first of all, we are going to see the topic of time period. Is the time period is defined as the time taken of a particle to complete one oscillation. It is usually denoted as T. So, for a complete revolutions, the time taken small t is capital T. Therefore, omega t equal to 2 pi, which means a complete rotations, making angle of 360. So we can find the value of from this data as t equal to 2 pi pi omega. Then the displacement of the particle executing simple harmonic motions, we can write as the functions of cosine y of t equal to a sine 2 pi by t into small t, or y of t equal to k cos 2 pi t by capital T into t. Whereas the t represents the time period. Suppose the time period t is replaced as capital T plus small t, then the function we can write as in functions of t plus t, which means y of t plus t equal to a sine 2 by t into t plus t. Similarly, we can write as the another term. Next topic, frequency and angular frequency. Okay. The number of oscillations produced by the particle per second is called as frequency. It is denoted as F, and the unit of frequency is per second or hertz. In symbol, H is Z. Mathematically, frequency are related to time period by F equal to 1 by T. So, equation 10.12 is a noticeable of equations. So, F equal to 1 by T. The number of cycles per second is called as angular frequency. It is usually denoted as Greek small letters omega. Comparing these equations of 10.11 t equal to 2 pi by omega and 10.12 f equal to 1 by t. So we can write as angular frequency and frequency are related. Omega equal to 2 phi f. So the unit of angular frequency is radian per second. And next, phase. The phase of a vibrating particle at any instant completely specifies the state of particle. It expresses position and direction of the motion of the particle at that instant with respect to the mean position. Y equal to E sin omega t plus phi naught. Whereas omega t plus phi naught is phi, called as phase of the vibrating particle. At time t equal to 0 second, which means initial time, the phase phi equal to phi naught called as epoch. So phi naught is called as angle of epoch. So this is a phase and phase difference. So we are executing and so particles of in the motions of simple harmonic motions. The equations is related as y1 equal to e sin omega t plus phi 1 and y2 equal to e sin omega t plus phi 2. So the phase difference del phi equal to omega t plus phi 2 minus of omega t minus phi 1. We get the phase difference between this both the equations y1 and y2 from phi 2 minus phi 1. In next topic, horizontal oscillations of a spring mass system. So the diagram of first one tells us a block of mass m. This is a block of mass m1. Okay. And the mass is attached into be a massless spring. With stiffness constant or force constants of a spring is called as K. We know that a force constant, we know that K, and then the mass is placed at a horizontal smooth surface, which means frictionless surface. That is, x naught be the equilibrium position or mean position when it's left undisturbed, which means there is no force acting on a mass. So f naught is the mean position. Suppose the mass is displaced. Suppose the mass is displaced through the small distance towards right from its equilibrium position. Right from its equilibrium position. So let F be the restoring force due to the stretching of the spring, which is proportional to the amount of displacement of the block. So we know that this is a one-dimensional motion. So the spring constant we know already. F directly proportional to x. So F equal to minus kx. So we know that the negative signs is tells us the restoring force always act opposite directions of the displacement. We know very well. This equation is called as Hooke's law. The restoring force is linear with the displacement. This is not always true. In case of if we apply very large stretching force, then the amplitude of oscillations becomes very large. Therefore, the oscillations of the system will be not linear, hence is called as non-linear oscillation. So from the Newton's second law, we can write the equations the particle executing from the harmonic motions. here f. So we know that f equal to ma. M here, a we can replace as t squared x by dt square equal to minus kx. So this m goes to here, minus of k by m into x. So remaining d square x by dt square. So already we have discussed this on the equations of 10.10. D square x by dt square equal to omega square y, which means minus omega squared y or minus omega square x. So replace this as 10.21 in left hand side. So we can put it at omega squared minus omega square x equal to minus k by m into x. So x cancel and minus will be neglected. So finally we get the frequency from this equations of omega squared equal to k by m. We get the value of omega. So root of k by m radian per second. So the frequency of the oscillations, the relations f equal to omega by 2 by we know. So 1 by 2 pi omega value becomes root of k by m. So frequency the unit of hertz. So from the frequency we can find the time period of the oscillation. So t equal to 1 by f. So the reciprocal of these equations of 10.23 2 pi into root of m by k in second. So notice that simple harmonic motions, the period of, which means the time period of oscillation is independent of amplitude. This is value for oscillation is very small, which means small. So x of t equal to a sin omega t plus phi and x of t equal to a cos omega t plus phi. So adding these equations of, we get the general solutions of the difference equations.